Hello friends. So welcome back to yet another exciting video about arithmetic. Now in this video our main aim is to learn about mixtures and partnership. They are nothing but the applications of ratios. Okay. So let's see. Mixtures is one of the interesting topics where some people face difficulty. Now, so first one is partnership, which is like a very easy concept, friends. Yeah. So suppose, and what is partnership? The word itself is so easy to understand that when two or more people come together and they start a business, so at the end of the year, some profit or loss happens. So that needs to be shared, right? For sharing, we want everybody's share. So how to split up a given number into various components? Which mathematical tool will help us do that? Yes, ratios. So here comes the application of ratios. So let's say there are three partners ABC. They invested 16 lakh, 12 lakh and 20 lakh each respectively for a period of, let's say A was there for 12 months, B was there for 8 months, C was there for 6 months. If I consider only investments, means in a way time period for all of them is same, then it is called a simple partnership. Okay. So ratio of the investments will be, of course, while distributing profit and loss, what do you feel? What all should be considered? How much everybody is invested as in terms of money and how much they have invested in terms of time. So money and time both will be considered, isn't it? It's very natural and logical. Yeah. Okay. So if I just consider only investments, that is nothing but it's called a simple partnership, assuming everybody is there for the same time period. So 16 is to 12 is to 20, which on further reduction can become 4 is to 3 is to 5. All right. Cool. Now, if I consider both of them, let's say the time periods are different, as in this case, 12, 8, and 6 months. That is called as compound partnership, just the term, no need to remember. So ultimate funda is considering both investment and time period. So ratio of the profits of, suppose partner A upon partner B, ratio of profits is nothing but ratio of product of investment and time period. Investment and time period. So you can see if the time period is same, this TATP will get cancelled, then it will be only ratio of investments, your simple partnership. And if time period is not same, then both should be considered, as in this case. So 16 into 12 is to 12 into 8 is to 20 into 6. Multiply bigger numbers and then you will reduce. You'll get 8, 4 and 5. But instead of that, can you do like this? First you reduce the given numbers only and then multiply to 16, 12 and 20, 4, 3 and 5, and here 6, 4 and 3. So you are at this stage, friends. 4 into 6 is to 3 into 4 is to 5 into 3. Don't be in a hurry to multiply. Again, we can see some common link. 3, 3 and 3 twos are, right? So 8, 4 and 5. This is our most reduced form. All right. So understand this. So don't multiply and make the numbers big and then worry about the reduction. So why did you multiply only? First reduce as far as possible, cancel out all the common terms across, and then remaining terms should be multiplied the way we did just now, 8 is to 4 is to 5. Okay. All right. And if nothing is mentioned about the nature of partnership, it should be assumed as compound, right? Now, one more thing, in case an employee or one of partner needs to be given a salary, then first deduct from the profit. So from that profit, salary will be removed, and whatever profit remains, that will be considered for the distribution among all the partners in the ratio of product of investment and time. Okay, got it? All right. Next comes mixtures. Yeah. Read the question. I hope you have read the question. A vessel contains milk and water in the ratio 3:5. The ratio is given, not the actual quantity. When 6 liters, this is actual quantity of water is added to this solution, the ratio of milk and water becomes this. How many liters of the solution was present in the vessel originally? Okay. So this is like an example of simple addition. Yeah, simple addition. Milk was 3 parts, water was 5 parts. Ratio is there, 3:5. So we can't say 3 liters and 5 liters actually. That is just one of the possibilities, but not the only possibility. Then we added 6 liters of water. After that, milk to water became 5:9. Correct? Did you see? Water is getting added. So the ratio of milk and water changed and it became 5:9. There are various methods of solving this. First method, equation. Generally that clicks first. So old values were 3:5. So can I say milk quantity is 3x? So water is 5x. Converting ratio into actual values, take a common multiple x, correct? And then water 6 liters. So total milk is 3x. Water is 5x plus 6. And the new ratio is 5:9. So how will you write this? Yes. 3x upon 5x plus 6 is equal to 5/9. Milk upon water. Cross multiply, simplify. At the end, you'll get x as 15. I hope you got this. So 27x was cross multiply 25x plus 30. Subtract. So 2x is 30. So x is 15. We got the common multiple x. Remember, to convert ratio into actual value, we need one hint. So that hint was the new ratio is 5:9 and water was added. Yes. So 5x plus 3x, 8x, and x is 15. So 8 into 15. So the old quantity was 120 liters. New quantity, if they would have asked, of course, plus 6, right? So 126 liters. This is equation method, friends. I hope everybody understood. Yeah. Second method is alligation. Yeah. So if you can see, you can consider water in vessel 1 and vessel 2. So water in vessel 1, the ratio is 3:5. So water was 5:8. Since that content is coming at the top right corner, so I'm writing here also so that you are connected in case you're not able to see that top corner. So water is 5/8. In second vessel, the water is how much? 6 liter, 100% water now. So I'll write it as 1/1. And resultant water was what? The ratio became 5:9. So water is 9 out of 14. Correct? 9/14. Then the same thing. We had done this in the previous video. Yes. 8 and 14, the common number in both the tables, that is LCM, 56. 8 sevens are, 14 fours are. So here it is into 56. So we have 35, 56, and 36. The denominator is common through what? 56. You can ignore it. 56 minus 36, yes, 20. 36 minus 25 is 1. The ratio is 20:1, friends. Correct? Yeah. So old vessel to the water is 20:1. Now this 1 in the ratio corresponds to actually 6 liters. That actual quantity we know, right? So 1 corresponds to 6 liters. So 20 corresponds to how much? Simple cross multiplication. Yes, 120 liters. So this way also we could manage this. Got it? Okay, I hope you're taking the notes properly. Third method of parts. And here, the logical approach, this is a very nice approach. If you see overall, what is not changing? In this overall transaction, what is not changing? Milk. Whatever milk was there earlier, same milk is there now also. Isn't it quantity wise? Just because you added extra water, so ratio terms changed. Yeah. So no change component is water. So our aim is to make the numbers corresponding to water same. So old term was 3, old number, and new term in the ratio is 5. So 3 and 5 both should become same. So that is LCM. Take LCM of 3 and 5. A number in the table of 3 and 5 both. Because in the ratios, we can only multiply both the numbers by the same number. So ratio won't be disturbed, right? A common number in the table of 3 and 5 both is 15. That is LCM. So let's make both of them as 15. So if 3 becomes 15, 5 will become 25 into 5 into 5. Yeah. And now if this milk 5 become 15, so into 3, so this will become 9 into 3, 27. So can you now easily compare, since the base is same, milk is same in both. So water was earlier actually 25 parts, now it became 27 parts. So an increase of 2 parts is because of, correct, those 6 liters. So 2 corresponds to 6 liters. This is that connecting link, friends. So this total 25 plus 15 is how much? Old wala chahiye na? So 25 plus 15 is 40. So 40 corresponds to how much? 120. Okay. All right. Simple. Simple addition. There are 2 more varieties, friends. Stay tuned. Yes, friends. So next variety is simple replacement. Now replacement. I hope you're comfortable with the word replacement. What will not change in this? So if you think logically, overall total quantity will not change. So whatever was removed, same was replaced back, right? By some other thing. So total quantity will not change. Let's see this example. Same numbers. Vessel contains milk and water in the ratio of 3:5. 6 liters of this solution is removed and replaced, but by only water. So 6 liters of the overall mixtures were taken out and replaced by 6 liters of water. It's all about application of ratio only, friends. Nothing new. Okay. The ratio now becomes 5:9. So how many liters of the solution was present in the vessel originally? Now whether they ask originally or finally, both are same, na? Because total quantity is not disturbed. So one way is same. Logically, the milk is 3x, water is 5x. But smartly, we are assuming the total as 8x plus 6, so that I don't come across the fractions. How smartly we are adjusting the 6 liters? Let's see. So I'm assuming the total in the vessel as 8x plus 6 and not just 8x. Check. Stay tuned. So from 8x plus 6, if you remove 6 liters, so the quantity remaining is 8x only, which you can easily split in the ratio of 3:5. That is 3x milk and 5x water. And then 6 liters of water were added. So new ratio is 5/9. Now this is exactly same as the previous situation. After solving, we got x is 15. So quantity was 8x plus 50, 8x plus 6. So 8x will be 120. So total was 120 plus 6, 126 liters. Very smart approach, assuming the total is 8x plus 6. Now through that no change component also we can do it, friends. Just check. Can I say originally the ratio was 3:5? Suppose the total quantity was T. From this you removed 6 liter. So total will reduce by 6 liter. Understand one thing, that one thing will not change. What? The ratio will not be disturbed. So whatever is remaining in the vessel now, ratio will remain same. This is the property of homogeneous mixtures. So milk and water is nothing but a homogeneous mixture. In that 6 liters also, friends, the ratio of milk and water will be 3:5 only. Okay. Now in this, we are adding 6 liters of water now. Okay. So the total got restored as T. T minus 6 mein वापस 6 add हो गया. So it became 6, T. But the new ratio is now 5:9. Just compare this situation, friends. It is same as simple addition, isn't it? So 3, 5, 5, 9. So 3, 5 will become 15, 25, and 5, 9 will become 15, 27. So water changed by 2 parts because milk is not changing from the second to third situation, right? The 2 parts is because of 6 liters. And finally, I want to find T, and T corresponds to this situation. So 15 plus 27. 15 plus 27 is 42. So if 2 corresponds to 6 liters, 42 corresponds to how much? How much is equal to 42 into 6 divided by 2? 2 3s are. So 42 3s are 126. You can take help of this 15 plus 25 also, that is 40 parts. That will be 120, but that is t minus 6 now. So t minus 6 is equal to 120. So t is 126. You may forget to add 6 in the exam pressure. That is why just take the final ratio 15/27. This was method 2 through no change component. So I hope you understood the second variety also, friends. Simple replacement. The first one was simple addition and now simple replacement. All right. Awesome. Let's move on to the next variety, simple percentage replacement. See the question. A vessel contains 75% milk solution. So if I assume total as, let's say, 100, I'm afraid to write at the corner because you might not see. So milk is 75, water is 25. Yes, first component is milk, second is water. So the ratio is 3:1. Ratio is important to play. 20% of this solution is removed. Means what? 20 liters are removed. In that, how much will be the milk and water? Same thing, just now we discussed, ratio will be same, na? 3:1. So 3x and 1x, 4x is 20. So x is 5. So milk will be 15, water will be 5. So 15 less, milk became 60 and water became 20 and a minus 5. But replaced by water. So 20 was added again. So now water is 40. So now milk to water ratio is 60:40. That is, yes, 3:2. Again, 20 liters of mixture was removed. Because this process is repeated 2 more times. So overall 3 times. Yeah, so 3 plus 2, 5. 5 fours are 20. 3 fours are 2 fours are. So now milk removed is 12. So 48. Now don't worry about the calculation of this water. Water gets reduced but gets added again. So total always maintained is 100, right? So water will be 52 automatically. Now the ratio is 12:13, right? Now the numbers will be slightly bad, but still you can do it. But just hold on. This is in detail process, but just wanted to make you aware about this so that we can understand the shortcut better. Just focus on the milk because milk is constantly reducing. Yeah, from 75 it became 60. Did you see this is 20% reduction? That 15 is nothing but 20% of 75. 1/5 of 75, that is 20%. From 60 it became 48. It reduced by 12. Just verify once again. 12 is nothing but 20% of 60. So now milk is 48. So next time also milk will reduce by 20% only. So 10% of 48 is 4.8. Cut double. So 9.6. So from 48 minus 9.6, so it will become 38.4. And remaining will be water. So milk is now 38.4%. This only let's write it as a shortcut, friends. Focus only on the milk, as milk is constantly reducing by the same percentage here. From 75%, if you remove 20%, it becomes 60%. Remove 20%, so it will become 48%, right? Why you were na? Then 20% again, so it will become 38.4. Yeah. Yes. I am writing this as fractions now. Original quantity was 75. 20% removed, so left, milk left is how much? 80%, isn't it? So 20% removed means 80% present. Every time 80% was present, so 80% will be multiplied 3 times. That is 4/5 will be multiplied 3 times. And if you just reduce it by doing smart calculations, ultimately this will be 38.4. Total is still 100, so 38.4%. Because the 75 is in terms of percent, na? So this will be automatically here. So 38.4%. Sometimes they may give you different percentages at every stage. First 20% was removed, then 30% was removed, then 40% was removed. So accordingly adjust the fractions. That's it. So these are nothing but the fractions present at every stage. Because at the end, you want milk present now. So fraction present at every stage. I hope you're comfortable, you're understanding, friends. Take the notes properly. Remember these examples only. They are acting as the concept builders. Now let's just generalize this process further and kind of let's make it a formula which we will remember as wine left formula. Wine is just like a pure substance. It is acting as a pure substance here. Yeah, you can say milk left formula also. So see the statement from a vessel which contains A liters of wine initially. That is, its capacity is A liters and it's completely filled with wine. Then B liters are removed. From this, you remove B liters. So now wine is A minus B liters, but it is replaced with water. So B liters of water came into picture. So total quantity is again A liters, but now after first such transaction, it became a mixture. Isn't it, friends? Yes. And this process you keep repeating n times. Then at the end, the fraction of wine left is what? Fraction of wine. The moment I said fraction of wine, I hope you should be comfortable. Wine upon total, right? Yeah. That is A minus B over A whole raised to n. Correct? A was the original quantity. B is the quantity you are removing and replacing every time. And n is the number of times you are doing this operation. Yeah. So milk left out of initial total. Remember, I'm connecting to the previous example is equal to 100 minus B was 20. We are removing 20 every time and replacing. So upon 100. And we did that 3 times. So milk is equal to 75 into this is 80 by 100 na ka cube. Same thing. So at the end you'll get 38.4. And this was percent. So this will also be percent. That's it. So this much should be good enough to build your base towards mixtures. Okay, friends. After this, we are ready to deal with any questions. Okay. So please recap, revise properly, make your notes properly. With that as a base, we will solve more and more questions in class. Thank you so much. Take care, stay safe, keep learning, happy learning.